Hello, my name is Greg Calvo. I'm the product manager for Speedline Electrovert. Welcome to the Electrovert Applications Lab, located at our facility in Camdenton, Missouri, where we have one of every model of machine that we build. That's including reflow soldering, wave soldering, and precision cleaning. Yes, I'm in the assembly area for the Reflow product line. While we're taking a video here, this is an OmniES 10 zone machine, and I'm just going to take a quick walk around and we can see the front. This is the load end, and this machine's just recently been QA'd, and it's actually has been prepared for shipment. So in just a few minutes it's going to be rolling back into the shipping area. So we're on the back of the machine, and we'll just do a walk around here to the front, to the unload end. And that is the OmniES 10 zone reflow soldering machine. So this is the OmniES 10 with the hoods open. We can see here that we have clear access to the top side of the heated chambers with the blower assemblies at the top. And then when we get down to the cooling section, the 10 zone oven is equipped with 3 cooling sections. This is actually a nitrogen configuration, but whether it's air or nitrogen, the 10 zone oven has 10 heated sections and 3 cooling sections. Okay, we have opened up the heating chamber and the cooling chamber on this OmniES 10 system. And the OmniES, as you can see, we have active isothermal topside heating, and we have a passive bottom side chamber. So I'm going to actually zoom in and focus on the isothermal heating system. As we can see that each heated section utilizes 2 finned heaters, one at the front, one in the back, and that each diffuser plate utilizes coined diffuser orifices, which actually improves the flow and improves the efficiency of the air dynamics from the compression chamber for better impingement of the convection reflow down onto the product and into the process area. The other thing I'm going to zoom in on is the thermocouple location. If you'll notice that for each heated section, the thermocouple is actually mounted over an orifice. So for the temperature control, we're actually measuring the process air, the temperature of the air as it exits the compression box and goes into the process area. What that does is it provides for a very efficient and very effective heating, and by measuring that process temperature right before it goes into the process area, it's actually a more accurate control and measurement of controlling the temperatures of your boards as it's going through the process areas. The 10 zone oven has 3 center width adjust assemblies. As I explained earlier, we have the precision linear guides at the load and unload end, and 3 center width adjust assemblies on a 10 zone oven. You'll notice that near the spike zone areas is center width adjust assembly number 2, and then right after the spike zone area, number 3. What this provides for is a very robust width adjust assembly mechanism. So what I'm going to do here is zoom in on this center one, and as you can see, the topside chamber actually has an area so that when that is lowered down, that it actually seals the center width adjust assembly from the process area. What that does is that minimizes maintenance that's required on those width adjust assemblies. I'm going to quickly touch base on the pin chain design and rail extrusion. This particular machine is a combination conveyor where we have pin chain conveyor and combination with mesh belt. What I want to point out Oh, and by the way, that beeping in the background is that we're actually lowering one of the hoods. That if you'll notice, number one, the rail extrusion, the robust design of the aluminum rail extrusion provides rigidity both width-wise of the rail, side to side, but also vertically from top to bottom. And what I want to point out with this is that if you'll notice that our pin chain actually returns in the rail extrusion. What that does is that, number one, for other competitive type systems where the pin runs back underneath the machine, you're actually cooling off that pin chain and then reheating it. That with this design, we're actually, once we heat up that pin chain, it stays heated. The second advantage to this is that it provides for a very smooth pin chain motion. So as your product is going through the machine, it sits on the pins, and with the pin chain being so close to each other, that it's a very smooth action, which reduces any opportunity for component movement as it's going through the reflow zones. We're standing at the load end of the OmniES, and what I want to do is highlight a couple of key points about the conveyor system. That at the load and unload end, we actually use precision linear guides as the support mechanism, and the linear guide actually provides 10 times the dynamic load rating as compared to a traditional ball bearing type system, which is more common on other reflow ovens. So we use this. The Electrovert reflow oven conveyor system is very robust, that is designed for smooth motion and minimal maintenance. So we're on the back side of the reflow oven, and we've got the electrical doors open, and just what I want to show is that the level of detail that goes into the wiring of these machines. Each one of these electrical panels is made in-house. What that allows us, it provides us with flexibility so that as customers configure a machine to exactly what they want, and as changes occur with that configuration, we actually control that in-house. I'm going to zoom in here on our I/O system. This is an off-the-shelf I/O. That these I/O cards are common across all Electrovert wave, reflow, and soldering machines. I do want to point out that as standard built into the base machine, every Electrovert reflow oven is UL certified and listed for factory automation.